So today we are going to discuss about equilibrium and triangle law, polygon law and Lami's theorem. So coming to the equilibrium, a body is said to be in equilibrium under the action of system of forces if all the forces on it are in balance, that is the resultant is 0. So that means, whenever you apply any force on a body, for example, a body is in a stationary condition. So whenever you apply a force on that stationary body, then because of that force, that stationary body may be in linear motion condition. That means it may be in moving condition. So that movement is either linear motion or that body may rotate. That means rotational motion. So because of the application of the force, the body may move linearly or it will rotate. So but even though if you apply forces, if that stationary body doesn't move linearly or if it doesn't rotate about at any point, then we can say that that body is in equilibrium condition. So even though if you apply number of forces, still the body is in stationary condition only, then we say that it is in equilibrium condition. That means the effect of all the forces on that particular body is becoming 0. So when the effect of all the forces on the body is becomes 0, then definitely there will be no change in the state of the body. So the state of the body is here stationary condition. So whenever the effect of all the forces on that body becomes 0, then still that body will be in stationary condition. If it is moving, means the effect of the forces are, we can say that the effect of the forces are present. So the effect of forces are not becoming 0. If that condition is, if it moves linearly or if it makes a rotational motion. But if it doesn't make any motion, then we can say that the resultant of all the forces are becoming 0, or we can say in another way, all the forces are in balance. Whenever all the forces which are acting on that body are in balance, then definitely the effect becomes 0. That means those forces won't affect that particular body. So that is the statement here given in this in this slide. So a body is said to be in equilibrium under the action of system of forces if all the forces on it are in balance. If all the forces are in balance, then the effect of all the forces will become 0. That means the resultant of all the forces becomes 0. So whenever the resultant of all the forces becomes 0, then the body will be in that original state only. So then we can say that that body is in equilibrium. So in this example, a 50 Newton force is acting in rightward direction. So another 50 Newton is acting on the left side of the body. So these two forces are equal and in opposite directions. So the sum of effect of these forces will become, so here it is in positive x direction, so plus 50, and it is in negative y direction, so we are going to take minus 50. So plus 50 minus 50, it will become 0. That means the effect of the forces is becoming 0, the resultant is becoming 0. So these two forces are imbalanced. So these are, whenever these forces are in balance, then we can say that that body is in equilibrium condition. So equilibrant, so the single force that is to be added to a given system to bring the system to equilibrium. So here equilibrant means the force which brings the set of forces in equilibrium is called an equilibrant. So the equilibrant is equal to the resultant force in magnitude but opposite in direction. So here 30 Newton, 50 Newton, two forces are acting on the right side of the body. So the resultant of these two forces is 80 Newton. So the resultant of these two forces is 80 Newton because they are collinear forces. So 80 Newton is the resultant force. So if you want to put this body in equilibrium, then you have to apply another force which is equal to this resultant force, and it should be in opposite direction. So that's why here we are applying a 80 Newton force, so equal in magnitude, and we are applying in opposite direction. So finally these two forces will be in balance. The two forces are in balance, 80 Newton and 80 Newton. When they are in balance, then the body will be, then you won't find any movement or any change in state of the body. That means that body will be in equilibrium condition. So resultant and equilibrium. So those are equal in magnitude and in opposite direction. And this resultant and equilibrium both are collinear and act along the same line. So here 50 Newton is resultant of both this 30 Newton and 40 Newton. So here equilibrant is equal in magnitude. So here 50 Newton, but it should be in opposite direction. So we are indicating with the opposite direction, and they are collinear. So that means they both act along the same line. So equilibrant, it will try to bring the set of forces in equilibrium or in balance. So the force which tries to, or which bring the set of forces in equilibrium is called an equilibrant. So conditions for equilibrium. So a rigid body which is subjected to coplanar forces will be in equilibrium under the following conditions. So the first condition is, so the algebraic sum of horizontal components of all the forces must be equal to 0. So when number of forces are acting on that body, so if you do algebraic sum of all the horizontal components of those forces, then if algebraic sum of all the horizontal components becomes 0, then we can say that that body may be in equilibrium, because this is only one condition to satisfy the equilibrium state. So here horizontal components or horizontal forces, they the algebraic sum of the horizontal components of all the forces must be equal to 0. Here P, a horizontal component of force, is acting towards right side. So another horizontal component of force is Q, is acting towards left side. So if you do algebraic sum of all the forces means, so here P, it is acting rightward direction. So here we are taking positive P, and Q is in negative direction, that is minus Q. So here algebraic sum of these forces must be equal to 0. P minus Q equals 0 means P equal to Q. So second condition is algebraic sum of vertical components of all the forces must be equal to 0. So if you add all the vertical components of forces, then the sum should be equal to 0. So this is second condition. Third condition is algebraic sum of moments of all the forces must be equal to 0. Here moments. So what is moment? So that we will discuss here. So here moment, here we are indicating with letter M. So here moment means moment of a force is the turning effect produced by the force on the body on which it acts. So here a force P is acting on a body. So in the figure, if you observe, a force P is acting on a body. So due to that force, that body will experience a turning effect. So because of the application of that force, if it turns, then the moment of force can be defined as the turning effect produced by the force on the body. So here the effect of the force is turning. So due to application of the force, that body is experiencing turning effect. So here moment of the force means turning effect produced by that force. So from the figure we can calculate that moment of a force. So moment of a force will be equal to product of the force and perpendicular distance from the given point to the line of action of the force. So here, so this is the force P. So moment of a force will be equal to force P into perpendicular distance. So perpendicular distance from the given point. Here the given point is O. From O to P the distance is R. This R is perpendicular distance to that application of force. So or the line of action of the force. So P into R is moment of a force from this given figure. So here R is perpendicular distance. For example, if any force acts inclinedly, so for this inclined force, if you want to calculate moment, then we can calculate here from the figure. So a force is acting with an angle theta. If you want to calculate moment, then we need force P into perpendicular distance. So perpendicular distance is here. So perpendicular distance to this line of action of force. So this is the force P, and the the perpendicular distance from that given point. So the given point is O. So from this given point we have to calculate this distance, perpendicular distance. So here if you observe in this figure, here a right angle triangle is forming. So from this right angle triangle we have to find out this perpendicular distance. So that will be equal to cos 90 minus theta into r. So finally moment of the force about point O will be equal to force P into perpendicular distance will be r cos 90 minus theta, that means r sin theta. So P into r sin theta is moment of a force P about point O. Or you can find out the moment of the force by resolving the force vertically also. So instead of calculating perpendicular distance, so if you resolve the force vertically, here the force P is acting at an angle theta. The horizontal component of this P is P cos theta. The horizontal component is P cos theta, and the vertical component, so this is the vertical component and this one is horizontal component. So vertical component is P sin theta. So finally the moment of a force will be equal to, so this P sin theta into R, P sin theta into R. So P sin theta into R will become moment of the force P about O. So you can directly calculate this moment by resolving the force vertically. So instead of calculating the perpendicular distance, by resolving the force vertically, you can directly calculate moment of the force P. So this is another method. So if you resolve the force vertically, then it is very easy method to calculate the force, to calculate the moment. So the moments are, depending on the direction of rotation, the moments are of two types: clockwise movement and anti-clockwise movement. So clockwise movement means, so whenever you apply a force, then that body may try to turn in clockwise direction. So if that body tries to turn in clockwise direction, then the movement you are going to get is clockwise movement. So anti-clockwise movement means, for example, if you apply a force like this, then the body will try to rotate or turn in anti-clockwise direction. So at that moment you are going to, that movement is called anti-clockwise movement. So clockwise movement and anti-clockwise movements. So this is clockwise movement,